Okay, so I found a cord for my microphone, so I'm going to make a video to try and help you out a little bit with your homework here. All right, so one of the first problems that looks to be pretty difficult here is a shape that looks like this. Let me go ahead and get my pen out here. Blue. Now, in the problem, I'm going to do different numbers, but I just want you to know that everything that I say here is going to apply to the problem that you have. Oops. Let's go ahead and move this guy up just a little bit. Okay, so in the problem you have something like this. You have some length here, like the length from here all the way across. In your problem it's 147. I'm going to make a different one. I'm going to call this 81 centimeters. Okay, that means the length from here all the way to here is 81 centimeters. Well, I hope you can see that this length, well, first of all, before we do anything, let's decompose this figure. This is a quarter circle here, another quarter circle, another quarter circle, and of course, in here is a square. All right, so we've got 4 quarter circles and a square in the center. Now, the radius of this quarter circle is equal to the side length of this square, which means that this little piece here and this little piece and this little piece over here, these are all the same length. Okay, so I've got 1, 2, 3 equal lengths that add up to equal 81 centimeters. And what that means is that the radius of our quarter circles is going to be 81 divided by 3, which is 27 centimeters. Okay, I hope that made sense. So you can kind of see that if I break this up into 3 equal pieces, I get this side, which would be the radius of my quarter circle. I get a side of my square, and I get the radius length of my other quarter circle here. Okay, so I take 81, divide by 3, and that gives me the radius and also the side length of my square. Those are the same. I'll say that again. The radius of the quarter circles and the side lengths of the square are all the same in this problem. Okay, so let's get started. We need to find what? The area and perimeter of this shape. Okay, I'm going to go ahead and delete all these little marks I made for myself. So what I need to do here is I'm going to find the area of the 4 quarter circles and the area of the square and add them all together. Well, guess what? The area of 4 quarter circles is just the area of a full circle. So my area for this shape is going to be equal to the area of the circle, which is going to be pi r squared, plus the area of the square here. Okay, so if I add these 4 pieces together, that gives me the full area of a circle, and that's why I don't have this divided by 4. And then the area of the square is just going to be, so this is 27. I'm going to multiply 27 times 27, but I'm going to write it down in formula version first. So I'm going to take this side and square it to find the area of the square. And here we go. So this is going to be 3.14 times 27 squared plus, well, side is also 27, so it's plus another 27 squared. Now, of course, for you, you'll be running this through a calculator. I'll bring up my calculator, and that's just what I'm going to type in. 3.14 times 27, whoops, squared, which is 729, plus 27 is squared again, which is equal to 3018.06. And that's my answer. Pause this because somebody's coming out of the bathroom. All right, let's keep going. So that's the area. When we calculate these things, run these things through a calculator, we got, what did we get? 3018.06. So let's put that down here. So this is equal to 3018.06. Okay, let's see here. Let's go ahead and try and fit perimeter in right here. The perimeter is pretty easy here. The perimeter is the distance around this shape. So let's say I start here. I'm going to have to walk all the way around the shape. So I'm going to have to walk across this line, this curved line, get to here, straight line, curved line, straight line, curved line, straight line, curved line. And then I'm back to where I started. So let's see, that's 1, 2, 3, 4 straight lines. And the straight lines are all 27, so I'll go ahead and put that down. That's going to be 4 times 27. Now, the curved lines, well, that's 1/4 the circumference of the circle, 2/4, 3/4, 4/4. So all the curved lines together is just going to be a circle with radius 27. So how do we find the circumference of a circle when we know its radius? Well, it's always going to be 2 times pi times the radius, which in this case I'll go ahead and put in parentheses, it's 27. Okay, and there we go. That's something you're going to plug into your calculator and find the answer. Let's go ahead and do that. So we've got 4 times 27 plus 2 times, do we have a pi button? Pi. Oh no, what am I doing? We're going to use 3.14. 3.14 times 27. So we have 4 times 27 plus about 6 times. So it should be about 270 something. And it is 277.56. That is our answer. The important thing is, I know you know how to use a calculator, so I'm glossing over that. The important thing is you know how to break this problem down into 1, 2, 3, 4 straight lines and the circumference of a circle. Okay. So our answer was 277.56. Okay, and that's that problem. So I hope you can take this. In your problem, down here we don't have 81, we have 147. So that makes things a little bit different, but you're using all of these formulas. The thing that's going to be different is the radius and the side length of the square. But decomposing into 4/4 circles and a square is still the same. All right? Let's try another problem. Let's do the next problem, actually. Okay, so here we go. All we're doing here is finding the area of this shape. Now, the book tells you that, what does it tell you? It tells you this distance across. And for my example, I'm going to use 25. Okay, 25 meters, let's say. Okay, and what we need to do is we need to find the area of this shaded section. So this is the area we want to find, this nice blue here. All right, so I hope you can see that we need to decompose this. This is a composite figure. We're going to break this down into a big circle, and I'm cutting out a smaller circle. So I'm going to find the area of the big circle and subtract the area of the smaller circle. Okay. So what I need to do here is I need to find the radius of the big circle. And I also need to find the radius of the small circle. Let's go ahead and find those things. Well, if the distance all the way across the circle is 25, that makes this radius here half of 25, which is 12.5. And look at this. The radius of this white circle here looks to be, and it is, half of the radius of the big circle. Yeah, this circle here is half the size of, its radius is half the size of the big one. So we're going to say that this is going to be 6.25 meters, of course, but I'm not going to write down all the units. So what I need to do to find the area of the composite shape, the area of composite, is I'm going to take the area of the big circle. I'm going to say area big circle. And I'm going to subtract the area of the smaller circle. Okay, now let's go ahead and come up with some formulas. The area of the big circle is pi times the radius, which is 12.5 squared, decimal point. And then we're going to subtract the area of the smaller circle, which is pi times 6.25. The radius of the smaller circle is 6.25 meters squared. Okay, that's a pi r squared minus a smaller pi r squared, or at least a smaller radius. And then you're going to run that through your calculator. So here we go. 3.14 times 12.5 squared minus 3.14 times 6.25 squared. Notice how I just run that all through the calculator. And that gives me my answer, which in this case is 367.96. What is it? It says round to one decimal place. So that actually rounds to 368.0 for this particular problem. And let's just take a look at the calculator real quick and you'll see why. So if I'm rounding this to this decimal place, I have to look back here. Well, this is closer to, this is greater than 5. So that rounds this up to a 0, and that takes this 1 up to, the 7 up to an 8. All right, so my final answer is going to be 368. But since I rounded to the nearest tenth, I need to say that by putting a 0 placeholder in the tenths place. What units? Ooh, I forgot units on the other ones. Well, the units should be square meters. And on the other one, it should be square centimeters for the area and centimeters for the circumference or perimeter. Okay, but the main thing is that you see that this is a big circle minus a small circle. Okay, last one. Dogs are going crazy. I'm almost done.
Okay, I'm just waiting in the bedroom for you.
Okay, I'll just stop it right here.